So I said about working with the, yes. So generators. So after this generators, వినిపిస్తుందా? వినిపిస్తుందా? గట్టిగా చెప్పాలా? గట్టిగా చెప్తావా? ఉన్నది ఎంతమంది? సౌండ్ పెంచు. గట్టిగా చెప్పి చెప్పి పోయింది వాయిస్. గట్టిగా చెప్పేది ఉండేది. హలో. ఎస్. So after this, after the generators, now let us see lambda functions. Lambda functions and or you can call it as lambda expressions. So let us talk about lambda functions or lambda expressions. After the generators, so lambda functions or anonymous functions. These are called anonymous functions. So this functions doesn't have any name. This functions doesn't have any name. So lambda functions are anonymous functions, and these functions doesn't have any name. There's no name for this particular functions. This functions doesn't have any name. So lambda functions are anonymous. So lambda functions are higher order functions. These are higher order functions. Higher order functions means the functions which can be defined. The functions which can be defined as lambda functions are higher order functions. The functions which can be defined as arguments, which can be defined as arguments, are called higher order functions. And lambda functions are inline functions. Inline functions. Inline functions. And these functions having only one statement. You cannot have multiple statements in lambda. How many statements you can have in lambda? Only one statement. Okay, these functions having how many statements? Only one statement. It cannot have multiple statements. Cannot have multiple statements. It can have only how many statements? One statement it can have it. So lambda functions are anonymous functions, and these functions doesn't have any name. Lambda functions are higher order functions. The functions which can be defined as an arguments are called higher order functions. Lambda functions are inline functions, and these functions having only how many statements? One statement. This functions is having how many statements? Only one statement, but cannot have more than one statement. So we can call it as lambda functions, or same thing, we can call it as what here? Lambda expressions. The function which is used only once, see, the function which is used only once, the function which is used only once is defined as a lambda function. The function which is defined, or the function which is used only once, It means frequently used functions, you don't define it as a lambda. Frequently used functions, you don't define it as what? Lambda. Frequently used functions, we cannot define it as a lambda, right? Okay, the functions which are used only once, so that functions are defined as what here? Lambda functions. Okay, so what is the syntax of writing a lambda here is, the syntax of writing a lambda is the syntax of lambda is lambda, it followed by arguments. Lambda, it followed by arguments. So arguments are optional. And here it is separated with a colon. It is separated with a colon and followed by how many statements? Only one statement, or you can call this as a expression. So lambda is a keyword. Lambda is a keyword which is used to define lambda expression or lambda function. Lambda is a keyword which is used to define lambda expression or lambda function. So what is the keyword you are using? Lambda keyword, which is used to define lambda expression or lambda function. So lambda, it followed by arguments, then followed by statement. The statement, or it is called as which one? Expression. Statement, or what is that? Expression. So just to see here how this lambda will work here. So we have not started PyCharm, right? So how you are writing a lambda is, I said lambda functions are inline functions. You are writing like this. So you can write a lambda with arguments. Lambda function can be defined. Lambda function can be defined. Can be defined. Can be defined. Okay, first one is with arguments, and second one is without arguments. So how many ways can you define the lambda function? A lambda function can be defined with arguments. You can write a lambda function with arguments, or you can write a lambda function without arguments. You can write a lambda function with arguments. You can write a lambda function without arguments. Okay. So there is a with arguments is there, and there is one more without arguments is there. So you are writing a lambda. So this is without arguments. So this is lambda without arguments. So this function doesn't have any name. But if you want to execute a function, you require a name or not? Yes. If you want to execute a function, the function required a name. But lambda is a function which doesn't have any name. Lambda function doesn't have any name, right? So main, now this lambda doesn't have any name. Name is not there. This function doesn't have any name. Okay. This function doesn't have any name. This lambda function doesn't have any name. Okay. So what will happen if I run this? Is it executed or not executed? Not executed. Is it this lambda is executed or not executed? Not executed, right? So I'm assigning this expression to one variable. I'm assigning this expression to one variable. What is the name of this variable is some a. So what is the name of this expression here? A. So I call this lambda expression by using a name called a. Now this is lambda without arguments. So this expression, I can call it either one time or more than one time. So this is called as inline. Inline means there is no separate memory allocated for this. There is no separate memory allocated for this. There's no separate memory allocated for this variable. Okay, there's no separate memory allocated for this variable. Okay, there's no separate memory allocated for this variable expression. So the memory for this expression is allocated as a part of which one? Main. So that is what we mean by inline here. So this is lambda argument. This is lambda function without argument. This is lambda function without argument. So in order to call a lambda expression, in order to call a lambda expression, it is assigned to a variable. In order to call a lambda expression, it is assigned to a variable. Using this variable, we can call lambda expression, or we can call lambda function. In order to call a lambda expression, it is assigned to a variable. Using this variable, we can call lambda expression or function. We can call lambda expression or what is that? Function. Okay. So here we assign to one variable. And using that, we can call this lambda function or expression. But lambdas are used as a higher order functions. Lambdas are used as a higher order functions, means the functions which doesn't have any name. The function which doesn't have any name, so that you can call it as higher order function. The function which doesn't have any name, that function is called higher order function, which can be sent as an argument. See, it is simple. You can write a lambda expression. For example, there is a lambda called add a comma b colon a plus b. There is a lambda called sub a comma b a minus b. There is a lambda called multiply. So a comma b colon a into b. So how many expressions I'm creating here? Multiple expressions. Now this lambda will take how many values? Two values and return a plus b. And this lambda will take how many values? Two values and return a minus b. This lambda will take again two values and return what? A into b. Okay, this lambda will take two values and return a plus b. This lambda will take again two values and return a minus b. And this lambda will take again two values and return what here? A into b division equal to lambda. This lambda again take two values and return a divided by b. So whenever I want to add it, I just call add function. Whenever I want to subtract, I call the subtract function. Whenever I want to divide, whenever I want to do multiply, I call multiply function. So whenever I want to divide, I just call which function? Division function by sending values. Then after that, I'm printing result 1, result 2, result 3, and one more result is 4. So I try to print result 1, result 2, result 3, and result 4. So when you run this, now you can see this value is a 30 and this is 3, and this value is a 50 and this value is what here? 2.5. So lambda is for writing a function having how many statements? Only one statement. And not only that, this is useful if you want to define a function, if you want the function should receive input as another function. If you want to write a function which receive input as another function, then you write lambda function with the arguments. So which is defined as another function here. There is a function 1 is there. So function 1 will take input as another function. Say, so variable name is f. Variable name can be anything, but here I take the variable name as what here? F. So I call this function f. Okay. It means function 1 perform the operation using, in this case, function 1 performs the operation using what? Another function. Function 1 performs the operation using another function. So here, function 1 performs operation using another function. So you are calling that function 1 by sending another function. Which function? I am sending different functions. So this is, I'll try to send one function saying that. So this is lambda 1. So which function I send it to this function 1? Lambda function. Okay. So I can call the function 1 by sending different types of functions. Okay, this is lambda 2. So this is lambda 1 and this is lambda 2. Again, I write here lambda. Okay, print this is, okay, this is lambda 1 and this is lambda 2 and this is lambda 3. So I call the function 1 by sending different lambdas. So f receives lambda 1 function and f receives lambda 2 function, f receives lambda 3 function. But I cannot write like this. I cannot send a function. Okay, lambda I can send. I can write a lambda function as an argument. I can write a lambda function as an argument, but normal function I cannot write here. I cannot write normal function and I can send it here. So if I write this is function. See, if I'm writing this is function, I cannot send it. So this may gives an error. Okay, normal function, I cannot send it. Normal function, I cannot send it. See here, it is given invalid syntax. A normal function cannot send it to another function directly as an argument. But which one I can send as an argument? Lambda. So this is called as higher order functions. Higher order function means the function which you can define as an argument of another function that you can call it as a lambda. That is called as which one here? Lambda. So dynamic behavior. If you want the function should have a dynamic behavior, means you don't define what operation it should be done within the function, but you send input as another function. So this is what this is what is the meaning of higher order function. This is lambda 1, lambda 2 and lambda 3. So we define it as an arguments. So within the function, for example, there is a calculator. Okay, there is a calculator. Calculator is there. The calculator received two values. Calculator received two values and it is also received a function. See, this variable name can be anything. Okay, it is also received function. Means calculator doesn't know what operation it has to be done. So calculator received two values and it is also received what? A function, and using this function it will do some calculations. Using this function it will do what? Some calculations. So what I'm saying, result equal to function. I'm calling the function by sending a and b and then I'm saying return result. But calculator is doing which calculations? You are not defined here. Calculator is doing what? Is it doing addition or subtraction or multiplication? Is it defined inside the calculator? No. We have not defined inside the calculator. Which operation the calculator has to be done, that is not defined inside the calculator. Which operation the calculator has to be done, that is not defined inside the calculator. It is not defined inside the calculator. Okay. So it is defined as an argument. So what I'm saying, result 1, calculator. So I'm sending 10, 20. So the value of A is a 10 and the value of B is what? 20. So what calculations this calculator has to be done? What operation this calculator has to be done, that you are defining it as an argument. Lambda, okay, x comma y, I said x plus y. X comma y, and then I said x plus y. X comma y, and then x plus y. Okay. So what is the meaning of this here? Okay. The function calculator is called by sending a value and B value and sending what here? Lambda. So F is nothing but what here? Lambda. F is nothing but lambda. Okay. F is the lambda to which you are sending A value as well as what? B value. And after that, what it is returning? A plus B value. And that value are returning into what? Result. So it means calculator is receiving a function as one input. So what is that function it is receiving? Lambda. What that function is receiving? Lambda. Result 2. So it means your function will have a dynamic behavior. So I'm saying here lambda x comma y, I said x into y. Okay, result 3 equal to calculator. Okay, so you don't require to write the functions inside that. So you are sending a function x comma y and x to the power of y. So I try to print the result 1, result 2 and result 3. I try to print result 1, result 2 and result 3. Result 1, result 2 and result 3. Now result 1 is 30, result 2 is 10 and result 3 is what here? 64. Okay, result 3 is a 64. Okay, yes. So this is how you are trying to do this lambda, right? So if you see the output now 30, 10 and one more value is what? 64. It means lambda function is sent to another functions here. But how many times this function is used by this function? Only one time. How many times this function is used by this function? Only one time. How many times this function uses this function? Only one time. Now there are some lot of predefined functions are there which uses lambda. There are a lot of predefined functions are there which uses lambda, like there is a function called filter. There is a function called which one here? Filter. Filter function is there. So what is a filter function will do? So there is a function called filter here. So what is the name of this function is filter. If you see this filter function receive the function and iterable. So constructs an iterator from those elements of iterable for which function returns true. Iterable may be either a sequence, a container which supports iteration, or iterator. If function is none, the identity function is assumed, that is, all elements of iterable that are false are removed. That are false are removed. Okay. So constructs an iterator. So there is a filter. So what is the name of the function here? Filter is a predefined function here. Filter is not user defined. Filter is what here? Predefined function. So constructs an iterator from those elements of iterable for which function returns true. Iterable may be either a sequence, a container which supports iteration, or an iterator. If function is none, the identity function is assumed. That is, all elements of iterable that are false are removed. It means filter does the filtering operations, but what to filter, you are defining it as a function. For example, okay, for example, there is a list. There is a list which contains some random values. Okay, there is a list which contains some random values. Okay, some random numbers are there. Okay, some random values are there. Okay, now this is a list. So from this list, I want to filter even numbers. From this list, I want to filter which numbers? Even numbers. I'm saying E equal to filter. So filter it followed by which one? Function. So what to filter? You are representing it as a function lambda n colon n mod 2 equal to 0. N colon n mod 2 equal to 0 and given list 1. So what will happen here is, okay, this filter function each time it will read one value from the list. Okay, what filter function is doing? Each time it is reading one value from the list. So what is the first value in the list? 1. So 1 is sent to lambda. Is it 1 mod 2 equal to 0? No, condition is a false. If it is a false, it will return or not return? Not return. Next value is a 6 and 6 is sent to the lambda and 6 mod 2 is 0. Yes, return 6. And next one is 8. Now 8 mod 2 equal to 0. Yes, return this. Next one is a 3. 3 mod 2 equal to 0. No. Next one is a 4. 4 mod 2 is 0. Yes. Okay, it means what this filter is doing, it is taking input as one function. So filter doesn't know what to filter. Okay, you can say that filter doesn't know what to filter. Filter doesn't know what to filter, right? What to filter, it doesn't know. What it has to be filtered, it doesn't know. But how it is, okay, filter doesn't know what to filter. Okay, it doesn't know what to filter. Okay, you are defining a function saying that, okay, filter this data. You are defining the function saying that filter this particular data. Okay, you are defining the function saying that filter this particular data. So what you're doing is it returns one iterator. So for value in iterable or iterator, then you are trying to print value. So what will happen here is it will return. So only which numbers? Even numbers. Suppose I want to filter odd numbers. I'll say filter lambda n colon n mod 2. N colon n mod 2 is not equal to 0. So I input this to the list 1 as a list 1. So for value in this is odd numbers and then print value. Now once you run this, now this is which numbers? Odd numbers. So if you want in the next line, you insert one new line. Now this is even numbers and this is what here? Odd numbers. Okay. So filter doesn't know what to filter. Filter doesn't know what to filter. Some x equal to filter lambda. So n mod 2, n mod 7 equal to 0. I want to filter the numbers which are divisible with what? 7. So for value in x and print print value, value next print value. So there is only one value it is written. That value is what here? 14. Okay. Yes. So filter returns only values for which function returns true. Filter returns only values for which function returns true. So what to filter you are trying to define as a what to filter you are defining it as an argument. So what to filter you are defining it as what here? Arguments. What to filter you are defining it as a arguments, right? So there is a filter. There's a function called which one? Filter. It required a lambda. So it's a dynamic. What function to be applied, you are defining it as a lambda, right? In the same way, there is another function called map. There is also another function which is called as a map. So mapping is nothing but applying it. Okay, mapping is nothing but applying. Okay, mapping is nothing but applying it. So what function you want to apply to the values of iterable? So return an iterator that applies function to every item of iterable. Return an iterator that applies function to returns iterator that applies to a function of every iterable. So return iterator that applies function to every item of iterable, yielding the results. If additional iterable arguments are passed, now function must take that many arguments and is applied to the items from all iterables in parallel. With multiple iterables, the iterator stops when the shortest iterable is what? Exhausted. So already we have seen this map function. Applying it. Mapping is nothing but what here? Applying. So you are applying one function to the list of values or collection of values. So that is done by using map. For example, there is a list. There is a list which is having some names. There is a list which is having what? Names. There is a list. There is a list of names are there. You have a list of names. This is a first name, this is second name, and this is what? Third name, like this. You have a list of names. Now I want to read each time one name and I want to apply a function called uppercase. I want to apply which function? Uppercase. So read each value and I want to apply a function called which one? Uppercase. I want to read each value and I want to apply the function called which one? Uppercase. Then what I can do is I can send a function as an argument, or suppose sometimes in application development, so you have a list. Assume that there is a list with some values. So 1 2 3 1 2 3 4 5. So there is a list of values 1 2 3 4 5, and assume that there is a 10, okay, some 20, okay, 30, 10 20 30 40, 10 20 30 40, and one more value is a 50. So I want to read a value from list 1 and list 2. I want to add this. Okay, now 10 plus 1 is 11, 2 plus 20 is a 22, and 3 plus 30 is a 33, and 4 plus 40 is a 44, and 5 plus 50 is what here? 55. So 1 plus 10 is 11, 2 plus 20 is a 22, 3 plus 30 is a 33, 4 plus 40 is a 44, and 5 plus 50 is what? 55. So I want to do this operation. Now for that I can go for which one? Map. Suppose one list is having only 3 values. One list is having only 3 values, and one list is having 10 values. One list is having only 3 values, but one list is having 10 values. So what will happen? It will stop when shortest iterable is exhausted. Shortest iterable is exhausted means now 1 plus 10 is what here? 11, and 2 plus 20 is a 22, and 3 plus 30 is a 33. That's all. Okay, so either list 1 or list 2, when shortest iterable is exhausted, it will stop it. But which function you want to apply, that you are defining inside a map. Okay, as a lambda expression. For example, we have seen already, there is a list contain strings. So 10, 20, 30, okay, 40, and there is one more string called which one? 50. So there is a string value which contain what? Integer. There is a string which contain what here? Integer. There is a string having integer like this. Now this is a list which contains strings, but inside the strings, which type of values are there? Integer values. Inside the strings, which type of values are there? Integers. Okay. Inside the string, which type of values are there? Only integer values are there. Inside the string, which type of values are there? Only integer values. Okay, but I want to convert all these values into integer. Then what I'm doing is, so this map will return one iterator. Which function you want to apply? Integer function to all these values. You want to apply float function. Okay, suppose this is iterator 1 and this is iterator 2, and I'm saying map. Apply which function? Float function. So what will happen in this case? Every time it will read value and apply integer. So every time it will read value and apply which function? Integer. Read 20, but 20 is a string. But you are applying which function? Integer. But integer, float, these are predefined functions. Integer and float, these are predefined function. Now I'm converting this iterator into list. I'm converting this iterator into what here? List. So there is a list 1 contains strings, and list 2 is having integers, and list 3 is having what here? Floats. List 1 is having integers, list 2 is having, yes. Once I run this, now you can see these are strings, and these are integers, and these are what here? Floats. These are strings, and these are integers, and these are what here? Floats. Okay. In the same way, assume that this is predefined. This is which one here? Predefined. So mapping is nothing but apply. So which function you want to apply, that you are defining it as one function argument, right? For example, yes. So you have a multiple list here. So there is a list one with some 10, 20, 30, 40, and 50. And there is a list two with 1, 2, 3, 4, and 5. Okay, I want to add this both the lists. Okay, then I take iterator and map lambda. So I take one lambda a comma b, a plus b. So list one comma list two. So what will happen here? This map function, what it will do is, it will take one value from list one and assign it to A, and it will take one value from list two and assign it to what? B, and then return what? A plus B, and take one value from list one and take one value from list two. So this value is assigned to A and this value is assigned to B, and then return A plus B, and take one value from list one and assign it to A, take one value from list 2 and assign it to B, and then return A plus B. So I'm converting this into a list. This iterator I convert into a list. Now you can see list 1, list 2, and list 3. And use a separator as a backslash. Yeah. So I want all this in the new line. I want all this in the new line. Now once I run this, now you can see 10, 20, 30, 40, 50, and 1, 2, 3, 4, and 5, 11, 22, 33, 44, and 55. Okay. Yes. Now which function you want to apply, that you are defining it as a lambda. Which function you want to apply, that you are defining it as a lambda. Okay. Which function you want to apply, that function you are defining it as which function here? Lambda function. That function you are defining it as which function? Lambda function, right? Yes. So this is mapping. Mapping is nothing but applying it. Okay, mapping is nothing but what? Applying it. So which function I apply? Addition. Which function I applied here? Addition. Like that you can apply any function. Like that you can apply any function. So there is also another function which is called as reduce. It is also one predefined function. It is also one predefined function, reduce. Reduce is also one predefined function. So there is a function called reduce. But this function reduce is there inside function tools. So function tools dot reduce followed by a function iterable and initializer, right? But all these are predefined functions. Okay. But all these are predefined functions. Now function tools dot reduce. Apply function of two arguments cumulatively. Apply function of two arguments cumulatively. So apply function of two arguments cumulatively to the items of iterable from left to right, so that it reduces the iterable to a single value. So reducing to the single value, but you want to reduce to the single value by applying which function? You want to reduce it to the single value by applying which function? You have to define that. Suppose that function, you can define it as a lambda. That function, you can define it as a lambda. Suppose there is a list. So I'm creating a list by using some range of values. So 10 comma 1, 10 comma 10. Okay. Now here list 1 is having 10 values. List 1 is having how many values here? 10 values are there. That is 10 to 100. List 1 is having how many values? 10 values. That is from 10 to what here? 100. List 1 is having 10 values. From 10 to 100 it is having it. Okay. List 1 is having 10 values. So that is from 10 to 100. Okay, 10 values, that is from 10 to 100. Okay, 10 values are there. So after that, now I want to reduce. I want to reduce it to one value. But by using which function you want to reduce? Okay, now there is a function reduce. But this function is there inside one module called function tools. See, there is one predefined module. What is the name of that module is function tools. Okay, function tools. So what I'm writing here is, I'm writing like this, function tools dot reduce. Function tools dot reduce to how many values? Only one value. But which function you want to apply? I want to apply, I'm saying lambda a comma b and a plus b. Means this is which function? Sum function. This is which function? Sum function. Okay, what is a value? A value is a 10 and b value is a 20. So 10 plus 20 is what? 30. And then 30 is a value and then 30 is what here? B value. 30 plus 30 becomes what here? 60. Then 60 is a value and 40 is what? B value. So it will take, yes, accumulated value and cumulated value. List 1. Now you can see what is the result 1 is. So you want to reduce it to one value, but using which function? You want to reduce it to one value, but using which function? You have to define. That function you are defining it as what? Lambda. Okay. So result 2 equal to function tools dot functions tools dot reduce. I'm saying lambda a comma b a if a is greater than b else b. Now this is which function here? Maximum function. I'm reducing to one value using which function? Maximum. So this will return maximum value. This will return what here? Maximum value. Result 3 equal to function tools dot reduce. And I'm saying here lambda a comma b a if a is less than b else b. I'm sending again list 1. Okay, now this is which function I applied here? Minimum function. Here I applied minimum function and here I applied which function? Maximum function. Here I applied maximum function and here I applied which function? Minimum function. Then after that I print result 2 comma result 3. I print result 2 comma result 3. Result 2 is 100 and result 3 is what here? 10. Result 2 is 100. Okay, result 2 is 100 and result 3 is a 10, right? So reducing, but again it uses which functions here? Lambda functions. So lambda functions are inline functions. So lambda functions are what here? Inline functions. And that takes how many arguments here? 2 arguments. Okay, lambda functions are inline functions. That takes how many arguments here? 2 arguments. Okay, right. So this is how it is. See, so this is where lambda functions are useful. Lambda functions are useful as which functions? Higher order functions. Higher order function means the function which can be defined as an argument. See, I'm writing function as an argument. Inline functions means these functions are used how many times? Only one time. These functions are used how many times? Only one time, which you cannot use it more than one time. Generally, if it is more than one time, you write a normal function. If it is more than one time, you write which function? Normal function. Otherwise, okay, then if you want to use only one time, then you write that as a lambda, right? Then next is next one is monkey patching. So before this monkey patching, we'll talk about function recursion. Function recursion or recursive. Okay, function recursion or recursive functions. Now, what is this function recursion or recursive functions? What is this function recursion or recursive functions? Okay, what is this function recursion or recursive functions? So what is this function recursion or recursive functions? So generally a function, a function, a function calling itself, function calling itself is called function recursion. Function calling itself is called function recursion or the same thing you can call it as recursive functions. Function calling itself is called a function recursion or recursive functions. Okay, if a function calls itself is called as a function recursion, or the same thing is called as a recursive functions. Function calling itself is called as a function recursion or recursive functions. Okay, so calling a function, it means in recursive function, calling function and called function both will be the same, right? In recursive functions, in recursive functions, calling function and called function both are what here? Same. In recursive functions, calling function and called function both are what? Same. Okay. So calling function itself is called as a recursive. Using recursive functions, complex problems can be solved easily. Complex problems can be solved what here? Easily. So most of the times function recursions are used like searching techniques, like it is very much useful in data structures. It is very much useful in data structures. So recursions are applied. Recursions are applied on data structures like what here? Okay, sortings. Okay, sortings, searchings, and what do you call it as trees, graphs, linked list, hashings. All this uses recursion only. So recursion makes it solving the problem more easier. Recursion makes it solving the problem more easier. Recursion makes it solving the problem more easier, right? So recursions are applied on data structures like sorting, searching, trees, graphs, linked list, and one more is what? Hashing, right? So that is where the recursions are applied. That is where recursions are used, right? That is where recursions are applied or recursions are used, right? So function calling itself is called function recursion or recursive functions. In recursive functions, calling function and called function both are same. Using recursive function, complex problem can be solved what? Easily. Yes. So in this, calling function and called function both are same. For example, I write a function 1. So print inside function 1, print inside function 1, and function 1 calls the function 1 itself. So function 1 calls again what here? Function 1. Okay. Function 1 calls again what here? Function 1 only. Function 1 calls again function 1. Now this is called which call? Recursive call. This is called which call here? Recursive call. Recursive call. So function one call itself. This is called as which call here? Recursive call. I call the function one here. I call the function one here, right? So when you run this, now you can see it is keep on executing the functions, right? So recursion means it is calling itself. Now control C you can press. So what will happen here is, so first it calls a main function, and main function calls which function? Function one. And what is the message I'll get here? Inside function one. And function one again calls the function one. What is the message I'll get inside function one? And function one calls again function one. What is the message I'll get inside function one? And function one calls again function one. What is the message again inside function one? So is it keep on executing or not? Yes, it is just like a loop. Okay, where you are repeating one statement number of times. Okay, but recursion also required some statements. If you don't give those statements, the recursion moves infinite. If you don't give those statements, what will happen is the recursion moves infinite. It is keep on calling it. How many times it is keep on calling it? Infinite number of times here. How many times it is keep on calling it? Infinite number of times. So the output is inside function one is executed infinite number of times. Infinite number of times because the function is calling how many times? Infinite times. So function recursion, to avoid this, function recursion required. Recursion required three statements. One is initialization statement. And second one is condition. And third one is update statement. So like a while loop required how many statements? Three statements. Like initialization statement, condition, and one more is what? Updation. Okay, initialization statement, function recursion required. Three statements, initialization statement. The second one is a condition, and third one is called which statement? Update statement. Okay, so we'll see tomorrow like how to work with this function recursion, and even I'll tell you how to work with modules and packages. So after that, we'll move to object-oriented programming, right? So we'll stop it here today, and tomorrow we'll continue this, right? Thank you. Yeah, this month will complete. If possible, I'll complete within this month.